Do you still see my screen?
Can you
guys hear us okay?
Hello to everyone who's joined. Thank you so much for coming. Can you hear us okay? No.
Yes.
Looks like someone's typing. Yeah. Okay. Thank you, Mike.
Are you talking from this one or from that one?
From the,
Okay.
yeah, because she's muted on there, so.
Okay.
Okay. Okay, well, I guess we'll go ahead and get started. Thank you for joining us tonight. We are here tonight to talk about drone technology and conservation. My name is Jordana Ellis. I'm from the Okanogan Conservation District, and I have with me Kelsey Mock from Aspect Consulting. Kelsey is not only a geologist and a water rights examiner, but she's also the drone pilot that helped me with this project that we'll be talking about later tonight. I am the irrigation planner, and we started this journey, if I could get my slides to advance, by I guess I should first talk about we're the Conservation District. We're the Okanogan Conservation District. We are a non-regulatory agency, and we work with landowners and other land managers to help them with their conservation goals and efforts. We have a lot of different programs that we do this with. We do it through habitat improvements. We have water resources, agricultural assistance, wildfire resiliency, recovery, and forest health, and we also have education, K through 12 in school. We started this project because we got the National Fish and Wildlife Grant to do a program for the Conservation Partners to Restore In-Stream Flow. So this program wanted to show how land managers could use current technology to improve their irrigation efficiency, because we wanted to try to improve in-stream flow, not only throughout the county, but specifically in 6 priority basins that were salmon habitat that had been identified for low flow. So we went and 11 different farmers allowed us to come out and fly drones on their property, and we used that information to help develop some irrigation water management plans. We used the drones to collect some high resolution imagery, some thermal maps, vegetation health maps, and elevation maps. Okay, so now I'm going to hand it over to Kelsey for a few minutes, and she is going to talk about the different uses for drones, and then we'll go back into a little bit more specifics about how we used it to help do some irrigation management. Cool.
All right, so yeah, the goal of the next few slides is to just kind of introduce drones in general and what kind of things that can be used for, specifically related to conservation. So generally the most common type of commercial drone on the market today is what's called a quadcopter, meaning it has 4 propellers. There are other types of drones like fixed wings, which generally cover larger areas, but are harder to control. And then like similar to quadcopters, hexacopters, which have 6 propellers, and they're generally used for carrying larger equipment. But the drone that we use and the most common type of drone is a quadcopter. So that's what's shown there. There's lots of different payloads that you can put on a drone, anything from just a regular camera to a thermal camera, multispectral cameras, which we'll talk a little bit about. And I've seen things like even gas sensors or LiDAR units, pretty much any type of sensor you could put on a drone if you could carry it. And so it's similar to using satellites, if you're familiar with satellite data, but it's on a smaller and more local scale. So and this image is just showing the spectrum, and you can see the visible spectrum, and then there's infrared and like UV light and things like that. So when we're talking about like multispectral, that's everything in the visible spectrum and then even outside of the visible spectrum. So using just a regular camera, you can collect high resolution imagery down to the centimeter scale. And you can also use the imagery to create 3D surfaces. And so that's what's shown here is a 3D surface of a farm, of a pivot. And you can see that part of the pivot has been cut already. And so you could use this type of data set to measure volumes of crop before and after cutting, so that you could measure about how much crop production using this method. So using just regular old imagery from a drone, you can process it to create something like a 3D surface that's shown there. And that's just up in the right hand corner, it's just a picture of a tractor just to show the resolution of one of these drone images. So some kind of use cases for regular drone imagery, like I mentioned, crop volume and height measurements. If you know the elevation of, if you take a drone flight over a field before the crops are grown and then you do it after, you can measure crop height, you can measure volumes of crops. Oh, are we not sharing our screen? Looks like someone's commenting.
That's what I was just looking for. I don't see it.
Are we not sharing our screen? Maybe we're not.
We were.
We were. Sorry about that. No, we don't want to. There you go. Can you see the screen now?
Yeah.
Okay. Perfect. Sorry about that. Thank you for pointing that out. Okay, well, I'll go back to that last slide just so you can see what I'm talking about. So this was the image that I was referring to with the 3D surface and then the high resolution drone image. Yeah, so this is another 3D surface image. Oops. This is another 3D surface image here with red being higher or lower elevations and the white over here being higher elevations over that same pivot that I was showing in the previous image. And so, yeah, so some use cases, you could use the imagery to do crop counts. So in GIS, taking the imagery and having it do automated counts of crops, or even just manually counting crops in an image, doing crop volume and height measurements using the 3D surfaces, monitoring land use changes over time, identifying land subsidence, so changes in elevation, measuring things like stockpile volumes. That can all be done just using regular drone imagery and processing it to create a 3D surface. And I'll talk more later about options for processing the data, but yeah, so those are just some examples of how you can use just a regular camera on a drone to collect data and use it for various cases. So this is just a couple thermal images and showing temperature. So I have the little legend on the corner there showing wet being like the darker purple and dry being the orangish color. And Jordana's going to talk later about how, like, some specific observations that we made in this project, but this is just to show what that thermal data set looks like and how it plots on a map. And so basically we're able to, at an individual pixel level, so like, inch scale, basically tell what the temperature is of the surface, and specific to agriculture, that can help us understand where water is getting applied to more or less, and where areas might need more water. So some use cases for thermal data are things like soil moisture and irrigation patterns, which Jordana is going to talk about in a bit. Groundwater seepage mapping. So if you're looking for where groundwater might be seeping, or where groundwater is coming into a stream, temperature differential, using it for animal counts and animal identification. So the images on the slide are showing both a regular image of some cattle and then a thermal image. So you can see that the cattle show up really well in the thermal image as white dots. And that's another thing that you could use GIS to do, kind of automated counting of using it for solar panel inspections, roof and building inspections, looking for things like energy leaks, insulation problems, wildfire mapping and identification, being able to send the drone out and map an area and look for hotspots that might lead then to a wildfire. So kind of like identifying it preemptively before it becomes a problem. Like I mentioned, stream temperature monitoring. The thermal camera can't see into the water, but it can see the surface of the water, so you can get temperature of the stream surface. And then search and rescue is another big, less conservation related, but big use case for thermal data. I will say too, if anyone online has questions at any point, feel free to shout or type them in the chat or shout them out. Happy to answer questions as we go. The last sensor that I'll talk about is multispectral, and that is primarily used for vegetation health maps. So what's shown on the slide here is a color spectrum between green being very healthy and red being unhealthy. And you can tell that it really highlights areas that maybe need additional either watering or pesticide management or fertilizer management, or just basically just shows the farmer that there's something going on in those areas that are unhealthy that needs to be addressed. Jordana will talk more about that as well. And so, yeah, use cases specific to multispectral, at least specifically the multispectral sensors that are on the market today, are vegetation, health, and crop management, as well as using it for plant species identification. So I've seen people use it to map out certain species. So for looking for like wetland delineation and things like that, you can use the multispectral data. Just works a little bit better than regular imagery to classify plant species using the imagery. And that graphic there is just showing like how the different data sets from the different images, both like the near infrared image and the green and red and blue images, will kind of combine to show you if it's a healthy plant or an unhealthy plant. And I think Jordana is next. Okay.
So, as we mentioned before, we use this technology specifically to focus on irrigation water management. So I wanted to talk for just a second about what is irrigation water management, and are you getting the most out of your irrigation system? So irrigation water management is essentially how much water are you applying and at what time and at what rate. And so we can use this information to help us get better results in our water application, our energy usage, our fertilizer application. It can help you save money in all of those areas, and it can potentially increase your crop yields by reducing your crop stress. And it can also help us protect ground and surface water resources. So we visited, as we talked about before, 11 different fields. And on this first one, it is extremely healthy. And one thing that we did notice was that there were several areas that were being irrigated that weren't being farmed. So at this specific field, there's about 7 acres worth of area that is being irrigated actively, but that is not able to be farmed. I don't know if you can see my pointer. This first bar here is a slope down from one field to the next. It's very rocky. And the pivot passes over it in a full circle, almost a full circle, three-quarter circle, I guess. And so they're irrigating this area, but not getting any of the yield production out of it. This whole band right here is actually a creek. And while that is probably helping with in-stream flow, it's not helping the farmer. And as a lot of our wildlife biologists probably would tell us, water directly from a pivot directly into a stream is not the best case scenario. Yes.
Could you describe what area you were pointing to? Because the cursor wasn't popping up.
Oh, okay. So the first area is at the bottom of the screen. The long red rectangle is the slope down from the higher elevation field to the lower elevation field. And then the extremely long wiggly rectangle in the middle is the stream. And then there's two small little pie-shaped areas that are just rocky outcrops in the field. One all the way at the bottom left and one near the top right that are just areas in the field that the pivot passes over, but is not being farmed. So for these specific areas, we're recommending to the landowner that they try to, if available, can upgrade their programming of their pivot to variable zone irrigation. And I'll show you a picture of what that would look like in just a minute. And so you can actually tell your pivot to turn off in certain areas as it passes over it. So in our next example, starting off looking at a field just from the roadside view, you're looking across this field and you think, wow, that looks really nice and green. Yeah.
There was a question on the chat of what was the irrigation method?
The irrigation method in the last one was a pivot, was 2 pivots. And this irrigation method that we're looking at right now, I know you can see a wheel line in the foreground, but that was just the border of the field. If you look closer out into the field, if you can see the picture, there is a pivot. And so this next one that I'm talking about is also a pivot. And I don't know if you can see this little drone taking off in the left-hand corner, in the bottom corner. So this is a picture from the road. And then next you're going to see the bird's eye view. So now you can see the same field that we were looking at from the road that looks so nice and green. And with this aerial imagery, we can see a lot of, just without the thermal and without the health, yet we can already see the patches and the areas where we're going to need some help with this field. So this is a great way for any land manager to just get an overall view with just the most basic drones of, wow, my field doesn't look as great as I thought it did when I was looking out across it. And so when we look closer with some of the thermal imagery that's helping us understand the water application, we can kind of see some really drastic effects of how it's dry on this upper. So this on the right-hand side of the screen is actually towards the north. So from the north down to the left-hand bottom, left hand of the screen is north to south. And as you look at this field, the pivot is right in the middle of the semicircle is the pivot pad, and the whole field is sort of like a bowl shape. And the topography of the field is not only sort of bowl shaped, but it also slightly slopes downward as it goes south. So as this pivot is moving from the higher elevation in the north down to the south, we're seeing it move a little bit too fast, and then it kind of gets down into that lower area where it starts to flatten out and bowl shape a little bit, and it starts to slow down. So we're having some unintended variable rate, probably, and then also, I don't know if you can see this black area all the way around the outside. And it didn't show up as well, but the area closer to the road at the very bottom of the screen there, that is where they had a wheel line set up as almost like a solid set, basically, because even though it was a wheel line, it didn't move. And also the pivot has an end gun. So this black area that you see at the very top of the screen was not only getting irrigated from a wheel line, it's also getting irrigated from the end gun. So we're going to call that over irrigation. So that's an area where they could even potentially cut off that end gun, which is actually not as efficient as you would think. Putting an end gun on a pivot can take your efficiency from the upper 90s down to the mid 70s. So that's one area where we're looking at. But something else that you're not seeing with the drones at all, and this is where irrigation water management comes in, is that this field's soils are also playing a factor in what we were just seeing. So we saw that really dry area before, and we can look at this soil map, and the area that is red is number 71, and that is let me make sure I say it right. Cashmont gravelly sandy loam, and then area 146 is an Ellis Ford silt loam. So in these two different areas in the same field, you're going from 70 to 80% sand in the red area to 70% more of silt. So that's two extremely different soil types with extremely different characteristics that behave differently with water. And we can see in this next slide, you can see the different sand, loam, and clay, the way that water behaves when it gets into those areas. And you're using the same amount of water and application in the same timing frame with two different characteristics of soils. So the water isn't behaving the same way. So another way that would help these fields is to use some of that variable zone and variable speed of the programming for the pivot. So that's going to help you change your water application into the different areas that behave differently. And so this was the health index that we could see. Some of this area that was in the sandy area is not responding as well as this silt loam area in the lower portion. And so just real quick, this is kind of what I was talking about with variable speed and variable zone. If you look at your screen, the one that just looks like a different shade colored pie chart sort of is where you can program the pivot to go different speeds in those areas. And then the variable zone, you can actually program your emitters to put out different rates when they reach that zone. So you can add in speed of how fast the pivot goes, but you can also change how much each emitter is putting out. So you can put out different amounts. You can even have some cut off. For that very first field that we looked at, when there were zones within it that we wanted to skip, you can tell those emitters to cut off as they pass through that area. So that would be a great way to help you work towards saving water and increasing your productivity and cutting down on your pumping costs. Okay, and so next we were going to look at a wheel line. This is a picture of the wheel line field from up above. It's being bisected a little bit by the canal. And as we look at the thermal from this, we can see the little red dot in the middle is the drive motor of the wheel line. And we can kind of see, if I go to the next slide, these zones that go all the way across the field in the big circled area where it doesn't look like it's getting an application as much as this black area down below the circle, the oval shape. So for this, I would say just from looking at that, you could recommend that the emitters could be changed. You could turn these lower emitters to a smaller application rate, and the emitters near the drive motor, you could have either a larger application rate with a different spray pattern or even directional spray patterns. And then also these straight lines are kind of indicating areas that are dry, and that could be one of two things. It could be the set time issues, or it could be spacing issues. So that would take a little bit more investigation to understand. And so just to look at the health from this same field, it doesn't look like there was a huge impact on the health in this area where it was drier. And it does look like there's a health impact in the zones that were vertical up and down that could be either the set time or the spacing. Okay, so that's kind of a big run through of just a few of the fields that we went through and some of the different observations that we made. And I'm going to turn it back over to Kelsey again to talk a little bit more about the actual equipment and things like that. Thank you.
Yeah, so now you're probably thinking, okay, well, how do I start using drones if I want to create those cool data sets that Jordana was showing? So there are lots of different drones and cameras on the market. It really depends on your budget and specifically what applications you're looking to use the drones for. So mostly I'm going to focus this on kind of what I call entry-level equipment. So the pros of entry-level equipment are that they're more cost-effective on the thousands of dollar range instead of tens of thousands of dollars. The sensor and the drone often come together, so you don't have to worry about buying a separate drone and a separate sensor and connecting them and getting them to work. The data that they create is generally smaller size as far as like storage, so you don't need a big computer to store it. And then there's a simplified data collection and processing workflow. So that's mostly why I'm focusing on the entry-level equipment. The cons of that kind of equipment are that it's only collecting what I refer to as relative data, basically meaning instead of collecting like we did for this project, temperature data or thermal data that gives you specific temperatures, you'll get a temperature map, but you won't get like individual pixels being temperatures. You'll just get a map that shows you relative temperatures. So like a colorized map like we looked at. So it's qualitative. Basically, you can't use it to measure temperatures, but you can use it to show you areas that are cooler or warmer. So because of that too, it's not as easy to compare data over time when you use more basic equipment, and there's no kind of data calibration associated with it. So because of that, there's a little bit of reduced precision and a little bit of reduced resolution of the data set. So the data that we used for this project is what I would call more like research grade data, but there are options for people that are just trying to get into this as more of like an entry level that you can get similar results as well. So just for a regular camera, some entry level recommendations. So the DJI Mini, that's a really good one for just like starting out, just taking pictures and video. That runs about $700. If you're looking to do like mapping, I'd recommend the Mavic, through DJI, they're a good brand. And then there's also Autel, it's another brand, and they've got like a smaller kind of quadcopter drone. For multispectral, DJI also makes the Phantom 4, which again comes with the sensor already on it. And is ready to go. That runs about $3,000. And then same thing with the DJI Mavic, has the sensor already on it, the 3M. And the Parrot Sequoia, is a separate, camera that you have to like connect to a drone that you already have. So that's kind of the options as far as multispectral goes. And then for thermal equipment, there's the DJI Mavic 3T, the Parrot Anafi thermal, and the Autel Robotics, EVO. And you'll see the thermal ones are a little bit more expensive. They run more like on the $6,000 range. But that's kind of still the lower end for thermal collection. So if you are looking for more higher end equipment, so what I call more research grade equipment, like I mentioned, the pros of that kind of data are that you're going to get absolute data measurements, which can be compared over time, and you can analyze them quantitatively. So that's, if you're interested in that and doing like more of having more research grade data for projects, then this would kind of be my recommendation. Also generally slightly better resolution. The cons is that, it requires additional training and knowledge around the data collection. There are specific workflows and things that just make it a little more complicated. The cost is more. And there are additional just considerations as far as collecting the data and processing it. So these are the kind of higher end equipment. So we got the Matrice 300 here today. That runs about $10,000. And then we have the Free Fly Astro, runs about $30,000, and the Wingtra runs around $20,000. And all of those come separate from the sensors, so you have to buy the sensors to put them on the drones as well. So these are just the drones themselves. And then you have the cost of the sensor. So this is the multispectral sensor that I generally recommend to people, the MicaSense Ultim PT, and it includes both thermal and multispectral. This is a brand new sensor, so this one wasn't available at the time that we were buying the equipment for this project. But this is nice because it comes with both thermal and multispectral. And then for thermal, there's also separate sensors you can buy. The ZenMuse is the one that we used for this project, and then FLIR has their own kind of sensor. So flying a drone. So just some requirements around flying a drone and what you need in order to fly a drone. So you have to register it with the Federal Aviation Administration. It's $5 for 2 years. There are two main options for how you can fly. Flying as a hobbyist or a recreational pilot, which is probably a lot of the farm operations, or you can fly as a commercial pilot, which means that you're flying to make money. And for that, you need to have a certificate. So you need to be licensed, which just requires taking a test. And you need to follow what are called the Part 107 rules, which are kind of specific rules that commercial pilots must follow. So someone like me. But for flying as a hobbyist, which is a lot of people that aren't trying to make money off of flying drones. Again, hobby or recreational purposes only. You have to fly your drone within visible line of sight. So that's generally for me about 3,000 feet away, but for some people, depend on how good your eyesight is, or how far away you want to risk it. But generally about 3,000 feet. And then you also have to give way to manned aircraft, fly at or below 400 feet above the ground, obviously depending on how close you are to an airport. If you are wanting to fly near an airport, you have to obtain approval. drone has to weigh less than 55 pounds. And they require you now to take this UAS safety test, but it's just an online test that you have to take. So it's pretty straightforward. So now I'm going to talk about imagery collection and processing a little bit. So for flight, there are two main ways that you can fly to collect imagery. You can do just manual flying, which is just using the sticks, controlling it, using generally a tablet, or if you have a smart controller, and taking images and videos that way. If you're wanting to do things like create maps and create 3D topography surfaces, you generally have to use what's called automated flight planning, and that's an image there of a flight path kind of zigzagging across the field. And so you would basically say, I want to fly this area, I want to cover it, and then the flight app would automatically create these zigzags for you, and then you hit go and you watch the drone do its thing, and then it comes back and lands. And so then from there, you take all these overlapping images and you create a stitch map and elevation service from them. So there's different solutions for both the planning and the processing. Generally, I would recommend for people that are just starting out to use these subscription-based programs. So things like Pix4D Fields, Drone Deploy, DJI Terra. They are all basically, they have an app that you use to collect the data. You draw a boundary around where you want to fly and you hit go. And then they upload the data and process it, spit out a map for you. So it's really like straightforward and doesn't require a ton of knowledge of how to collect the data or anything like that. So very beginner friendly. It generally runs about $100 to $300 a month. And there are monthly subscriptions. So if you don't want to do a yearly thing, you could do it by month. And like I said, you can access these via a web browser, so you don't need a supercomputer to process them. But I will say that only certain programs allow for processing of thermal and multispectral imagery. So if you are interested in that in particular, I would make sure that you look into whichever program you decide to use and make sure that it accepts that kind of imagery. There are also free solutions. I've used the Open Drone Map before, and that's good as like an open source. If you're generally okay with computers, that's a good one to use. And then I haven't used Skybrowse, but I found that one when I was prepping for this, and that looks like another decent free option if you're looking to just try out something free. So yeah, I think that's all that we have, but we will take questions, and thank you for attending and listening in.
Yes, thank everybody for tuning in. I really appreciate it. And a special thank you to Kelsey.
Yeah,
For
absolutely.
coming down, and not only that, but for the amazing drone flying. She's the one that took all the drone images and did all the drone flights for this project. So I really appreciate that.
It was fun. Yeah.
I don't know how to see.
We have some questions coming in.
Oh, nice. How do I see that? Oh, there we go.
Oh, okay.
Okay. Got someone typing. Cool. Yes. Oh, thanks, Mike. Thanks,
Yeah.
Mary. Appreciate it. And yeah, feel free to follow up with Jordana and or I if you're trying to.
Yeah, if you want to hear more in detail about the project, or if you have any questions about this grant or the project that we did or what we did afterwards, feel free to email me. I'll put my email in the chat here.
Should I put my email in there too?
Yeah, sure. Of course. How was the soil overlay generated through NRCS mapping or via the drone? As I used the NRCS data, I used the web soil survey for all of those. Cool.
Right.
Well, thank you everyone for tuning in. I really appreciate it. And thank you for the audience very much. And we will have this up recorded on the Okanogan Conservation District website as soon as we are able to process it. And so feel free to share it and tune in and ask questions after that. Thank you. Okay.